Hi everyone. In the last class we discussed about the finding the solutions of the initial value problem and one boundary value problem also given by using the Laplace transformation concept or inverse Laplace transformation concept, right? This is a great advantage, already we discussed. These are the applications, right? In that application, in one of the application we taken in the previous class, finding the solution of the initial value problem or boundary value problem by using the concept of the Laplace or inverse Laplace transformation. Here, now it is an application to the integral equations. But before finding the solution of the initial value problem or boundary value problem, they are the differential equations. As the problem is defined at a one point, it is the initial value problem. It is defined at the 2 points. Conditions defined at 2 points is the boundary value problem, right? But we know that how we are going to find the solution of the differential equation. Or before that, the formation of the differential equation. What is meant by differential equation? How we write the differential equation, how we determine the order and degree, the properties related to the information related to the differential equation we know. But here it is integral equation. This is I think this is a new concept for you, right? Applications to the integral equation. Now I am trying to give some introduction to the integral equation, then we find the solution of the integral equation, right? Here it is integral equation. Integral equation is a equation. Integral equation is a equation in which it appears, in that equation appears one unknown function, that function to be determined, that unknown function to be determined, right? An integral equation is a equation. In that integral equation, one unknown function appears, so that such type of integral equations are called, the type of equations are called, it is the integral equation. Here it is, listen, in this, suppose if I am taking f of t is equal to g of t plus integral a to b k of k is a function of t comma u f of u du, right? Where g of t and k of t comma u are known. These are the known functions. And if you take that means here a to b is there, but if they are the fixed bounds, here the classification of the integral equation we will discuss here, right? These are the known functions. And f of u, if you take the limit b is equal to t, you will get the function of t, or better to write it f of u or some f of t. It is a function, it is an unknown function. This function to be determined. The objective of this one is what? This f of t is to be determined by using this, by equating to 0. Then only it is the equation, no? G of t plus integral a to b k of t comma u f of u du, right? This equation is known as integral equation. In this case, g of t and k of t comma u known and f of t is unknown function. We have to determine this unknown function. That is our objective. But here it is, in this the k of t comma u. K of t comma u is called, here k of t comma u is called kernel of the integral equation. Kernel of integral equation. If the constants, if two constants, if a comma b are two upper bounds, I'm concentrating on the only upper limit, that is b is fixed and constant, b is fixed and constant, such type of differential equation is called Friedland differential equation. As both upper limit a and b are constants, so this equation is called Friedland integral equation. Sorry, not a differential equation, integral equation. Suppose if b is the variable, b is equals to t if I am taking, as it is, this equation is the Friedland equation, right? Friedland equation. If I am writing that equation f of t is equals to g of t plus integral a to t k of t comma u f of u du, this equation is called Volterra equation, Volterra integral equation, Volterra integral equation. Is it clear? This is the definition, this is the classification of the differential equation, sorry, classification of the integral equation based on the upper limit, upper bound, right? See, just a recall. The equation of this form, we say that it is integral equation. Here one unknown function is appear, that is f of u. That is function we have to determine, the function is determined, right? That is our objective. where g of t and k of t comma u are known functions. Here k of t comma u is called kernel of the integral equation. If a comma b are fixed constants, so such integral equation is called Friedlein integral equation. If b is equals to t, it is a variable, right? The upper limit or upper bound is a variable, so that we say that it is a Volterra integral equation. This is the introduction to the integral equation, right? This is the style of the integral equation. Next, here now to find the solution of the, to find solution, it is nothing but to find f of t. To find the f of t, unknown function we have to determine. Yes, to find the f of t or to find the solution of integral equation, just I am going to recall one or two concepts which are learned in Laplace transformation concept, right? Convolution property, right? First one, it is convolution. Just we recall the one by one. Convolution, not convolution theorem, it is convolution. Here it is, first one, convolution is, suppose the convolution of f of t and g of t, the function of t, the convolution of f of t and g of t is denoted by f star g, and it is defined as integral 0 to t f of u into g of t minus u du, f of x into whatever it may be, f of t minus u du, or this is same as integral 0 to t. Yes, here it is g of u into f of t minus u du. This is the convolution of the two functions f of t and g of t. Next, coming to convolution theorem. By based on this, we derive the convolution theorem. This is a convolution property. This is the meaning of the convolution. If let f of t, g of t two functions, then the convolution of f comma t is denoted by f of t into g of t. Star stands for into, or f star, simply we write it f star z, which is equals integral 0 to t f of u g of t minus u du, or sometimes we are writing f of x g of t minus x dx. This is same as, if I am writing that this is the f star g same as g star f, no? In that manner we are writing 0 to t g of u f of t minus u du. But by convolution property or convolution theorem, just I am trying to recall, convolution theorem or convolution property, convolution theorem or convolution property, here it is, you know that if Laplace transform of f of t is equals to, or direct I am writing in the inverse Laplace transformation, if L inverse of f of s is equals to f of t, L inverse of g of s is equals to g of t, then L inverse of f of s into g of s is equals to integral 0 to t s f of u g of t minus u du. Is it clear? F of u g of t minus u du. Integral 0 to t f of u g of t minus u du, it is nothing but convolution of f of f and g, no? This can be written as f star g, right? So it is L inverse of f of s into g of s is equals to f star g. That implies taking Laplace transform on both sides. Laplace transform of f star g is equals to f of s into g of s. Yes, f star g, it is nothing but Laplace transform of f of t into g of t is equals to f of s. Here it is g of s. This is a convolution property here by using the convolution theorem. Or this is same as, listen, but f star g is, you know that, or better to write, but you know that from this, what I am writing, f star g already you define, no? F star z same as Laplace transform of, this is very important, Laplace transform of integral 0 to t f of u g of t minus u du is equals to f of s into g of s. This is same as, sometimes I am going to write integral 0 to t, here it is g of u f of t minus u du is same as f of s into g of s. Is it clear? Yes, remember this property here. F star g is the f into z stands for f star g stands for integral 0 to t f of u g of t minus u du or g of u f of t minus u du, right? If you go for the convolution theorem, you know that L inverse of f of s into g of s is equal to this one, right? So this is replaced by f star g. Yes, that is L inverse of f of s into g of s is equal to f star c. You take out Laplace transform on both sides or L inverse to the right side, so it becomes L. Okay, 1 by L inverse it is L. L of f star z is equal to f of s into g of s. L of f star z is what? Laplace transform of integral 0 to t f of u g of t minus u du. From this we are writing f of s into g of s. This is same as this is the convolution theorem, we recall, right? You know that this one. Next one. Yes, Volterra equation can classified into two types. Volterra integral equation can classified into two types. One is Volterra integral equation of first kind. No need, just yes, here it is. An integral equation is of the form g of t is equals to some lambda is a constant, lambda into integral 0 to t. Yes, it is variable, it is always the upper limit is always a variable, right? K of t comma u f of u du. So here it is g of t is known, f of t is unknown. So this is called Volterra integral equation of first kind. Next, if we have the equation like this, f of t is equals to some y of t or f of t. Not only here it is y of t I am writing. Y of t is equals to another unknown function we have, f of t plus some g of t, no problem, integral lambda into integral 0 to t k of t minus u into f of u du. That means kernel is always a function of the difference t minus u, right? If we have the integral equation in this form, we say that it is a Volterra integral equation of second kind. Whatever the equation is given, our objective is we are going to find the solution of that equation, right? Yes, we are using to solve the integral equation to find the unknown function, we are using this property. This is very important. Integral 0 to t f of u g of t minus u du is equals to f of s into g of s. Right. This is a Volterra equation of first kind. This is a Volterra equation of second kind. Volterra integral equation of first kind and second kind. Next, direct we go for the problem. See, if you solve one problem, one or two problems, we'll get a clarity on that. Right. Next, integral equation of the convolution type, last property. Integral equation of convolution type. We are solving this type of problems only. Integral equations of convolution type. The integral equation y of t is equals to, suppose if I am taking the integral equation y of t is equals to f of t plus integral 0 to t k into t minus x or t minus u, that is whatever the variable is existing there, into y of x dx. Y of t is equals to f of t plus integral 0 to t k of t minus x y of x dx, in which the kernel k of t minus x is a function of the differences, same Volterra equation of second kind, is a function of differences of t and x, is a function of difference t minus x only, and the integral equation is known as integral equation of the convolution type, right? Now using the definition of the convolution, we rewrite the equation. This equation can be written as, you know that the definition of the convolution, what I am writing here, y of t is equals to f of t. Just now we written the here, if I am taking the f of f star z is equals to what we written, f star z is equals to integral 0 to t. Here it is f of u g of t minus u du. Here also in the same form, no? Right? By using the definition of the convolution, this can be written as f into z. That is nothing but f of t into, that is y of t. This is y of t into k of t, right? By using the definition of the convolution, we can write y of t into k of t, right? Taking Laplace transform on both sides for this one. K taking Laplace transform on both sides. Laplace transform of y of t is equals to Laplace transform of f of t plus Laplace transform of y of t into k of t, right? Yes, Laplace transform of y of t, if I am taking f of s, Laplace transform of f of t, you will get some function. Here it is plus Laplace transform of y of t into Laplace transform of k of t. From this, after simplification, you will get the solution, that is y of t, right? This is the required solution. Is it clear? Yes, now we are going to solve the problems on integral equations of convolution type. That means simply we can replace this term by the y of t into k of t, and taking the Laplace transform on both sides and simplifying, you will get the solution. Yes, this is the process. The procedure is very easy, right? If we know the convolution property or convolution definition, right? Now coming to the problem. Solve the integral equation. F of t is equals to 1 plus integral 0 to t f of u into sine of t minus u du, and verify the solution also, and verify the solution. Yes, whatever the solution you will get, yes, you are going to verify whether the solution is right or not. This given integral equation, see, if you see one problem, you will get the clarity. F of t is equals to 1 plus integral 0 to t f of u sine t minus u du. Say this is equation number 1. Next, using the definition of the convolution, we have integral 0 to t f of u g of, standard definition I am writing, g of t minus u du is equals to f star g or f into z. Here in this case, that implies integral 0 to t f of u sine of t minus u du is equals to what I am writing here, f of t into what we have, sine of g of t minus u, g will get sine of t minus u, what we have, sine t. So say this is equation number 2. From 1 and 2 we have, right, f of t is equals to 1 plus integral 0 to t f of u sine of t minus u du is replaced by what, f of t into sine t. Is it clear? Say this is equation number 3. What is your objective in the given integral equation? Solve the integral equation means you are going to find this f of t, unknown function involving, right? Here one is known function. Yes, an integral equation is the equation. Yes, in that equation it appears one unknown function. One unknown function is f of t appears here. By solving this equation we have to determine f of t, right? So our objective is we are going to find the f of t, right? We have this statement, no? We have f of t is equal to 1 plus f of t into sin t. Now taking Laplace transform on both sides, we have Laplace transform of f of t is equals to 1 plus Laplace transform of f of t into sin t. Yes, which is equals to 1 plus Laplace transform of, from the definition of the convolution, we can write it Laplace transform of f of t into Laplace transform of sin t. Right, here it is Laplace transform of f of t. Right, here it is Laplace transform of f of t is equals to f of s. Now it is capital F. F of s, 1 plus f of s. Sin t is what? 1 divided by s square plus 1 square. You take out the terms to the right side, this f of s term to the left side, sorry. Yes, and common f of s. What we have? 1 minus 1 divided by s square plus 1 is equals to, sorry, I did a mistake here. When I am taking Laplace transform on both sides, you will get the Laplace transform of 1 also. Here it is Laplace transform of 1 is equals to 1 by s. Here 1 by s. Is it clear? Yeah, which is equals to 1 by s. That implies f of s into s square plus 1 minus 1. Plus 1 minus 1 get cancelled, s square divided by s square plus 1 is equals to 1 by s. That implies f of s is equals to, as you take out these two terms to the, this term to the right side, s square plus 1 divided by s cube. So which is 1 by s plus 1 by s cube. Now Laplace transform of f of t is equals to f of s, no? This can be written as Laplace transform of f of t, which is equals to 1 by s plus 1 by s cube. Now we need to find f of t here. You take out this L to the right side. So L inverse of 1 by s plus 1 by s cube. So which is same as L inverse of 1 by s plus L inverse of 1 by s cube can be written as 2 plus 1. Yes, positive integer. L of 1 is equals to 1 by s. L inverse of 1 by s is what? 1. Yes, here it is 1 by s to the power of n plus 1. Yes, and being positive integer. It is n factorial. 2 factorial divided by, here it is, sorry, t to the power of n divided by n factorial. That is t square divided by 2 factorial. 1 plus t square by 2. So our solution is f of t is equals to 1 plus t square by 2. This is a solution. This is a solution of the given integral equation. Yes, the solution of the integral equation is what? 1 plus t square divided by 2. This is a great advantage of the Laplace transformation. Just we are using the convolution property, taking Laplace transform on both sides, we will get the unknown function, that is f of t. It is given by 1 plus t square by 2. And problem not yet completed. What is given? Yes, you have to verify whether your solution is right or wrong. Right? So verification means here it is from 1. Now we go for the verification here. Right? If I'm going to concentrating on the right side, RHS, if you simplifying with this f of t, yes, RHS, what is there? 1 plus integral 0 to t f of u sine of t minus u du, right? One plus integral 0 to t, f of t is 1 plus, I have to verify whether f of t is equals to 1 plus t square by 2 is a solution of the given integral equation or not. So after here, that means LHS already f of t is there. After simplification, what you are going to expect if you are taking that 1 plus t square by 2. So here it is f of t is what? F of u is 1 plus u square by 2 sine t minus u du. This integration by parts, this is u, this is v, right? You know that just I am going to apply this one. Yes, without, here it is Actually it is u square by 2 is there. So u square is there. 2 times you need to apply integral u into v. So I am going to use the Bernoulli formula for generalities. U is what? 1 plus u square by 2. Yes, v is sin t minus u. Just you write the derivatives of u. Right, the derivative of u is what? 0 to u by 2, that is u. The integration of v with respect to u. The integration of sine of t is a constant, right? I don't know about t value. A sine of t minus u integration with respect to u is minus cos t minus u. Okay, next u derivative is what? 1. Cos integration is sine. Yes, here it is. Actually it is minus, but divided by minus 1, no? Divided by minus 1, so minus into minus plus we have. Is it clear? So cos integration is sine. Sine of t minus u divided by minus 1. Next, one derivative is 0. The integration of this one is what? Sine is minus cos. Here it is minus cos of t minus u divided by minus 1. Is it clear? Sine integration is minus cos divided by here t minus u is the coefficient is minus 1, right? A plus cos of ax plus b divided by a is equal to minus 1 is there. So here it is minus, here it is minus into minus, here it is minus. Now in this case, in this way you are going to multiply. So the integration is what? 1, first one 1 plus u square by 2 into cos of t minus u, alternatively positive and negative. Next negative u into minus sine of t minus u, right? Next positive plus 1 into negative cos of t minus u, where the limits are from where to where? 0 to t. And before substituting the limit, just you are going to simplify without minus terms. 1 plus u square by 2 cos of t minus u, minus into minus plus u sin t minus u minus cos t minus u where 0 to t. Right, we go for the upper limit 1 plus, right, upper limit 1 plus t is equals to u square by 2, 1 plus t square by 2, right? Cos of t minus t, cos 0 is equals to 1. Next, plus t into sin of t minus t, sin 0 is 0, minus cos of t minus t, cos 0 is 1, right? 1 we have. Next one, if you go for the lower limit, 1 plus 0, 1 into cos t, are you following? If you go for 1 plus 0 into cos t minus 0, cos t, 1 plus 0 is 1, that is before minus is there, minus cos t. Okay, next here u is equal to 0, 0 into anything, it is 0, right? Here already minus is there, that minus into minus plus here t minus 0, here it is plus cos t. See, here minus cos t plus cos t get cancelled, which is equals to 1 plus, the terms write it, remaining terms write it, 1 plus t square by 2 minus 1. Yes, plus 1 minus 1 get cancelled, which is equals to 1 plus t square by 2. This is our f of t, no? So the solution is verified. This is a verification, right? What is the reason for verifying whether the solution is right or wrong? If you go for the new method, right, that means compared to, we have the several methods for finding the solution of the integral equation, right? In that, here we are choosing the Laplace transformation concept or Laplace transformation method is to find the solution, right? The solution is same, the solution is correct, the solution is satisfying the given integral equation. This is the problem. Next, problem. Solve the integral equation sine 2x is equals to y of x plus integral 0 to x minus t into y of t dt. Don't get confused here. The variables are different, right? Y of t, some here previous f of t is given, next some u of t, some v of t is given, whatever it may be, right? So now coming to solution, just you follow the procedure. As given integral equation, so I am writing better to write this y of x. Y of x is equals to 3 sine 2x minus integral 0 to x minus t y of t dt. Yes, integral equation is of the convolution type, means the kernel is always is a function of the difference of x and t here. General, the difference of u and t, k of u minus t, right? Okay. Now from the definition of the convolution, by the definition of the convolution, integral 0 to x minus t y of t dt is equals to, so what I am writing, x minus t y of t dt is equals to, here it is, so as it is, f of, what is that, f of y of t, write it in this way, no problem, y of t x of into x minus t. So this can be written as integral 0 to x, here it is y of x into y of x into x, y of x into x by using the convolution property. Say this is 2. From 1 and 2 we have y of x is equals to 3 sine 2x minus this term simply we can replace by y of x into x. Now taking a Laplace transform on both sides, Laplace transform of y of x is equals to 3 into Laplace transform of sine 2x minus Laplace transform of y of x into, direct I am writing here, y of x into x, that is the Laplace transform of x, that is Laplace transform of t. Don't get confused here, x instead of x, t is there, so it is f of s, simply we can write it f of s. 3 into Laplace transform of sine 2t is what, 2 divided by sine square s square plus 2 square, 2 divided by s square plus 4 minus f of s into Laplace transform of t is equals to Laplace transform of t to the power of n is equals to s n factorial divided by s to the power of n plus 1, 1 factorial divided by s to the power of 1 plus 1, it is 1 by s square. So you take out the term to the right side, left side, f of s if you common, 1 plus 1 by s square is equals to 6 by s square plus 4. So here it is f of s into s square plus 1 divided by s square is equals to 6 divided by s square plus 4. That implies f of s is equals to, directly you can write it, 6s square divided by s square plus 1 into s square plus 4, s square plus 1 divided by s square plus 4. What we are going to write here, this can be written as s or Laplace transform of y of x, x is given, is equals to 6s square divided by s square plus 1 into s square plus 4. Right, that implies y of x, you need to find the y of x unknown function, no? L inverse of 6s square divided by s square plus 1 into s square plus 4. As if you are applying the resolving to partial fractions, or if you write the terms, or it is 1 by 6s square, it is there, no, 1 by s square plus 4 or 1 by s square plus 1 minus 1 by s square plus 4. So we have s square plus 4 minus s square minus s square minus 1. It is 3 we have. So okay, it is 4 minus 1, it is 3. We can write it 2s square. Before write it, L inverse of 2s square of 1 by s square plus 1 minus 1 by s square plus 4, which is L inverse of 2s square by s square plus 1 minus 2s square by s square plus 4. Right, if you are finding this, you will get the answer 2 into L inverse of s square by s square plus 1. How we are going to find? You know that 2 into L inverse of s square divided by s square plus 4. Right, then you will get the answer. Let's evaluate it. L inverse of s square divided by s square plus 1. Okay, this is the way of solving the integral equation. Like that, we go for the another problem. I will give some problems. This is the way. You find out this, you will get an answer. Solution is e to the power of minus t into 1 minus t whole square. The solution is here the solution is f of t here, f of t here. Here the solution f of t is equals to 1 minus t. Solve these three problems and verify it whether your solution is correct or not. Next, yes, just now we solve the problems on the integral equation when the integral equation is of the convolution type. Next, Abel's integral equation. Abel's integral equation. Right. An integral equation is of the form integral 0 to t f of u divided by t minus u all whole to the power of alpha du is equals to g of t. An integral equation is of the form integral 0 to t f of u divided by t minus u to the power of alpha du is equals to g of t is known as Abel's integral equation, where here it is f of t is unknown function that can be determined. It is unknown function that is going to determine, and g of t is known function, g of t is the known function, and alpha is the constant, is lies between 0 and 1. Yes, an equation is of the form integral 0 to t f of u divided by t minus u whole to the power of alpha du is equal to g of t is called Abel's integral equation. F of t, where f of t is the unknown function, g of t is a known function, alpha is the constant which lies in the open interval 0 comma 1. Right, now how we are going to find the solution of the Abel's differential equation, sorry, not the differential, integral equation. Right, this is the definition. Now we take one problem and finish it. Solve integral 0 to t f of u du divided by square root of t minus u is equals to 1 plus t square. 1 plus t square. This can be written as integral 0 to t. Here it is f of u into square, in the denominator square root is there. It is t minus u whole to the power of minus 1 by 2 du is equals to 1 plus t square. T plus t square. So this is equation number 1. Yes, by the definition of the, again we use the convolution. By convolution, the definition of the convolution, we have integral 0 to t f of u t minus u whole to the power of minus 1 by 2 du is equals to f of t into t minus u, that can be taken as t to the power of minus 1 by 2, say this is 2. From 1 and 2 we have that can be written as f of t into t to the power of minus 1 by 2, 1 plus t square. Now taking Laplace transform on both sides, Laplace transform of f of t to the power of minus 1 by 2 is equals to Laplace transform of 1 plus t square. So which is same as Laplace transform of 1, Laplace transform of t, Laplace transform of t square. So here it is by using a convolution, Laplace transform of f of t, not here it is small, into Laplace transform of t to the power of minus 1 by 2. Here Laplace transform of 1 by s square, 2 by s cube. Right, which is nothing but f of s. Yes, Laplace transform of t to the power of n, same. Here n being positive integer, we can write it. Here t to the power of 0. Direct t to the power of 0 is there. Yes, Laplace transform of 0 factorial divided by s to the power of 0 plus 1, 1 by s. T to the power of n. 1 factorial divided by s to the power of 1 plus 1. 2 factorial divided by s to the power of 2 plus 1. Here it is not an integer, here minus 1 by 2 is there, which is greater than minus 1. N is greater than minus 1. N being a real number which is greater than minus 1. So what I am writing here, gamma of n plus 1. Gamma of n plus 1 is what? T to the power of minus 1 by 2 can be written as 1 by 2 yes, it is minus 1 by 2 there, no? Minus 1 by 2 can be written as n plus 1, we need to write it. Plus 1 or minus 1. 1 minus 1 by 2. Sorry, minus 1 by 2 plus 1. Minus 1 plus 1 by 2. Yeah, Laplace transform of t to the power of minus 1 by 2 is gamma of 1 by 2 divided by s to the power of 1 by 2. That is gamma of n plus 1 divided by s to the power of n plus 1. So n plus 1 is equals to 1 by 2. So n is equals to 1 minus 1 by 2, which is minus 1 by 2. So n is equals to minus 1 by 2, right? So we can write it minus 1 plus 1 by 2. Okay, n plus 1. N is equals to gamma of n plus 1 is equals to 1 by 2. N plus 1 is equals to 1 by 2. We can write it this. So which is same as 1 by s plus 1 by s square plus 2 by s cube. So you take out the terms to the right side. F of s is equals to, here it is s to the power of 1 by 2 divided by gamma of 1 by 2 of 1 by s plus 1 by s square plus 2 by s cube. So you multiplying with f, that is L of f of t. F of s is nothing but L of f of t, which is equals to 1 by gamma 1 by 2 is root pi. S to the power of 1 by 2 divided by s. 1 by s to the power of 1 by 2. Again we have. Next, s to the power of 1 by 2 divided by s square. 1 by s to the power of 3 by 2 here. Next, plus 2 divided by s to the power of 3 minus 1 by 2. 3 minus 1 by 2, 6 minus 1 by 2 is s to the power of 5 by 2. So, to take out L to the right side, f of t is equals to 1 by root pi, L inverse of 1 by s to the power of 1 by 2 plus L inverse of 1 by s to the power of 3 by 2 plus L inverse of 2 into s to the power of 5 by 2. So, this is root pi. Here it is L inverse of 1 minus 1 by 2. Here 1 by s to the power of n plus 1 minus 1 by 2 plus 1, n plus 1, right? Here it is 1 by 2 minus 1 in the previous. Okay. Next, L inverse of 1 by s to the power of 1 by 2 plus 1 plus L inverse of 2 into 1 by s to the power of 3 by 2 plus 1. So, which is 1 by root pi. Yes, n being a real number, what I am writing? S to the power of n plus 1. As gamma of inverse of 1 by s to the power of n plus 1 is equals to, it is n factorial divided by, not factorial, we get t to the power of n divided by gamma of n plus 1, right? Okay, which is equals to what we have? T to the power of n divided by gamma of n plus 1, gamma of 1 we have. So we have, it is s to t to the power of minus 1 by 2 here, plus it is t to the power of 1 there, 2 into t to the power of 1, 2 into t to the power of 1 plus 2 into, or 8 by 3 into t to the power of 3 by 2. Verify it by using gamma function, 8 by 3 into t to the power of 3 by 2. So this is your f of t. Right, next continuation. Like this is the problem on Abel's integral equation. The same way you are going to solve one problem on this. The same method. Integral 0 to t t into 1 plus t, that is nothing but t plus t square. Here in this case you are going to apply this formula, L inverse of 1 by s to the power of n plus 1 formula, t to the power of n divided by gamma n plus 1. Apply that formula, you will get that conditions. Okay, this is about the Laplace transformation, and these are the two applications for solving the initial value, boundary value problems and integral equations. The last class I given one boundary value problem, just your y dash of 0 is not given, So you take y dash of 0 is equal to a. After getting the final solution, just you take the boundary value condition, then you will get the a value. So then substitute the a value, which is the required solution. Okay, thank you. This is about the Laplace transformation and inverse Laplace transformation applications. Next class we go for the Fourier series.